forward-backward contractor. In this exercise, I will illustrate how the forward-backward contractor works on an example involving a quadratic constraint. So assume that I have a given point C which belongs to a box given here and a real number. It belongs also to an interval. I consider the set of all x and y such that there exists one center C inside this box, such that there exists also a radius r, so that this constraint is satisfied. Here I should have r square. I will have to write in Python a program for the associated contractor using a forward and backward contraction. I will recall how it works, and so the constraint is given as x minus cx square plus y minus cy square equal R2. So this can be represented by a syntactic tree. So I will have x here minus cx, and there I will build a new variable, let's say a. I have also the same for y, cy, here minus, and I will build the variable b. So this corresponds to a and this to b. I will add the two of them, plus, and I will excuse me, maybe the square before. I will go inside a square function, power 2, and I will build a new variable which encloses the square, and I will call it a2. The same here, I will have b2. So here it's a2, here it's b2. Then I have the variable r square, and I will have the variable r2 here, and this should be equal to the sum of a and b. So how each of them, so I know that this one belongs to an interval x, this one also belongs to an interval cx, and so on, and I will want to contract all of them. Of course, if I contract all of them, I will contract also x and y, and I will build my contractor. cy, and this one should belongs to r. Oh, the idea is to start from the leaf and to propagate the information upward in this direction, and so on up to the equal. And then I will propagate backward. So in red it will correspond to the forward procedure. So this one will belongs to A. How A is computed? A equal to x minus cx. So I have A. The same, so I have A. What about B? B equal to the interval y minus cy. Now I have to propagate here and here. So I will write a2 equal to the square of the interval a, and also b2 equal to the square of b. I propagate the information up to a2, and I am here now. And I continue with the plus. So R2 is equal to the, excuse me, I will write R2 like this. It's a variable, so like A2 and B2. And here it will be the square of the interval R. So I propagate, I am here, here and there. And now I will take this information. So this one, this variable and this variable are related by the relation R2 equal to A2 plus B2 due to this. So I will contract the three variables all together, and I will write like this: C add, the contractor for add. I will contract the interval R2, A2, and B2. So this procedure will contract all of them, and I have started the backward propagation. And I will continue there. I will obtain, since A2 is the square of A, I will write here square of R2 R. So this will propagate downward in this direction, and now R is contracted. I mean, all the information from X, Cx, Y, and Cy have reached R. And now I have to continue in this direction. So I will have the same for A2 and B2. So square of A2 A, and the same for B. B2 B. And as we can see, I am now going to this direction. What about here? About here, I know that AY equal to B plus CY. This can be translated into C add of Y B and CY. And of course I will have the same for X. C add X A and CX. So this the information from R has reached here, and everybody has been contracted. So of course, at the end of the algorithm, I will only return this interval and this interval, and this will build the contractor for the set S given here. With Python, I will program the contractor CX, and for this I will start with an old program named my estimator, which has been done in some exercises before. I will save it, file save as, and I will call it my ring, because we'll draw a ring. .py. Okay, so I remove many things. Maybe later I will use here vibes. I will use probably my box, and also my contractor, to use the basic contractors. I import everything. This one, I will remove this. I will comment, or I will comment many things. Whoop, comments. This one I will not need it. This one is the main program. Comment. Okay, I will start with this. My contractor, I will call it C like contractor in ring. The contractor admits as input all variables that are here: x, cx, y, cy, and so on. X, y, cx, cy, and r. Okay, and what will I return? Only x and y. So if you prefer, these are parameters. There will be intervals, but they are parameters. They have not the same status as this one. The contraction only is performed on x and y. I will have to implement the algorithm given here on the right. The first step is a, the new variable a, it is an interval, equal x minus cx. B equal a minus cy. A2 equal to the square of a. So here it is a backward implementation. B2 square of b. R2 is the square of r. And then I will have to call the contractor C add. So it will be R2 A2 B2, this, equal to C add of R2 A2 B2. Now I will have A2 A equal to C square of A2A. The same for B. B, and also the same for R, but I don't need to contract R, so I will not write it. Now I will have X A C X equal, so as written here, Y B and C Y, X Y A and C X equal to C add, and the same here for Y B C Y, Y B C Y. Okay, now I have programmed my contractor, which was asked in this question here. The second question, using a paver, so a Civia type algorithm, which will bisect boxes and starting with a big initial box. And I will also use the contractor implemented just now. I have to provide an outer approximation for S for this set, which of course a subset of R2, so I will be able to draw it. So I will have to implement a Civia algorithm in Python. So what about the Civia? The Civia here will take as an input a box. That's why I will call it X box, and it will contain both both X and Y. So the first step is I will check. I will take this for instance. If X is smaller than a given size, let's say 0.3 or something small. In this case, if it is small, I will return. Okay. Then, if not, what will I do? I will draw the box in a color, so the color will be X, of course, and it will be blue. So why blue? Because the border will be black, but inside it will be, let's say, cyan. Cyan means that it is not solution. But of course, I will draw everything as non-solution because since I will contract, when I will draw the box, only the part that has been contracted will appear as blue. So now I will do the contraction. X dot y x dot x equal to C in ring, and here I will again call this probably normally I should have called it X and Y because the order above was X and Y. X, Y. Then here I will have to enter an interval for Cx. So let's say to be consistent with what I have here, Cx will be 1, 3, C, Cy will be 2, 4, and the radius will be 4, 5. That's why here I will put interval of 1, 3. This is for Cx. Here 2, 4. Only one comma. And the last one is 4 and 5. So this one will be the parameters. Then I will draw the contracted box. So here, for instance, I will draw, well, I will take this one. I will draw the box in yellow. Yellow means uncertain. Without border. Then here I will call in a recursive manner Civia once more with x dot left and x dot right. So I have implemented my Civia. Now for the main. For the main, I will have to initialize vibes to make a new figure. I will call it, for instance, let's say ring, one ring. Here I will initialize something like this, quite small. Okay, not too big box, not too big window. I will remove this. I will initialize x, the box x will be, for instance, an interval between minus 10, 10, minus 10, 10. Then I will call Civia with the box as input, the box x. Then I will end drawing. Okay, I start vibes. It is here. I run the program. Okay. We can see here all yellow boxes and all the blue part correspond to what has been contracted.